Welcome to Newscast 105. Today, I'm doing an interview with Miss Fusion and Miss Fission. Just going to ask them some questions about their life and how it works being a nucleus. So, Miss Fusion, tell me about your life.
Alright, well, it all started back with my parents, two nuclei, and they had very low masses, or not a lot of money, low incomes, and they didn't have a lot to start with. But when they met, they decided to combine to form one nucleus and one family, and they were living a positive life. They were positive charged, and they're happy and energetic. And then they became close together, and they're moving fast through life, and then they were fast enough that they overcome all the obstacles, they overcome all the forces, and they combined to be fused together.
Wow, that's just an amazing story. Miss Fission, could you tell me about your life?
Well, mine's a little different. Mine's not as happy. Well, they were all together. We were all happy as a family. And then one day, my parents weren't as happy anymore with each other. They found two other people. And so they split into smaller, and they just divorced, and it was very sad. And so it caused a chain reaction, so it happened so here I am.
Happened to
Yeah,
them
they just kept splitting, didn't they?
Splitting.
How tragic. Well,
It's very sad.
I mean, Miss Fusion, I'm very glad you had such a great life, and Miss Fission, I'm sorry about your parents' divorce. But that's what we're here for. And thank you. This is Elizabeth reporting from Newscast 105. We'll see you later.
Bye.
This just in, breaking news about the power lines down in Georgia. Now we're off to Sarah with all the live coverage.
Power lines down all over North Georgia. We're going to start needing to convert to nuclear energy. Although it's mostly used for nuclear weapons, it can power our generators. Now to commercials.
A form of nuclear decay. It's when the spark force is not strong enough. The nucleus unstable. It breaks apart and gives off matter. Gives off energy. Whoa.
Hi, I'm an unbalanced atom. And if you donate 1 electron a day and we can bond ionically, then I'll be a happy balanced atom.
Hi, I'm an unbalanced atom. If you just share a few electrons with me, I can be balanced by covalent bonding, and I can be so happy. It just takes a few electrons.
Go.
Hi, and welcome to the Kids Show, where we teach your kids all about different subjects. Today's subject is science.
Science!
Go. First step.
So, first you write the symbol of the element or polyatomic ion that has the positive oxidation number or charge. Second and third step.
Next, you X out the sign or remove the sign, so really the sign isn't there anymore, and then you move, for example, on the I, the 1 goes to the K, and on the K, the 1 goes to the I, and then you get K1, I1, which reduces to this, and that is potassium iodide.
So now we're going to be talking about how to name covalent compounds. So we are with the following: S2Cl2. So this is sulfur and chlorine. We see that there's number 2s at the bottom of each element. Now we have to learn how to name these. So when you see the number 2, that gives you the prefix Di, or D. So if we're going to name sulfur first, then we would say D-sulfur. We just put the prefix in front of the actual element. Now if we're going to move on to chlorine, we would see the 2. And a rule is that the second element is always given an IDE suffix at the end. So we would do D-chloride. Originally we would do chlorine, but since it's the second element, we would do chloride.
So next we're learning about the periodic table of elements. So the periodic table is divided into 3 sections. We have metals, which are the blue. Then we have the metalloids, which are the green, and the
metals, which are yellow. There's also hydrogen over here. The metals have some properties that the non-metals don't have. Metals are a lot more reactive than non-metals because they have less electrons in their outer shell than non-metals do. They're also more shiny and malleable, and they're also better conductors than non-metals. Overall, the periodic table is arranged by atomic number, which, for example, in nitrogen is the 7, and the atomic mass would be the 14. Overall, it's arranged by these columns, which are called families or groups, and the rows, which are called periods. There are 18 families or groups and about 7 rows. And that's all you need to know about the periodic table of elements for today.
Hi, we know college is rolling right around the corner, so next up we have some people from NDU, Nuclear Decay University, to speak to you about the different sororities and clubs to join.
Sarah, and I'm from the Gamma fraternity. Here at Gamma, we have no mass, no charge, and no problems. If you find yourself in the Gamma fraternity, it's usually because you've been in alpha or beta first. The reason for this is that after alpha and beta decay occur, there's always gamma rays that are emitted. So if you don't like it at beta or alpha, you can always be emitted into gamma. A little to know about our history is that we all travel at the speed of light, and when the university holds competitions, we're always the most penetrating form of radiation out of all the fraternities.
Hi, I'm Abbie, and I am in the Alpha sorority. You might know the Alpha sorority from being very similar to the Helium fraternity, and that's because they have an atomic mass of 4 and the positive charge of 2. And to be an alpha, you have to be made of 2 protons and 2 neutrons. And in the process of this, we usually use a force on electrons in atoms. And so we pull off the electrons away from the atoms and leave behind the charged ions. And so once you are an alpha, you're given off from the decaying nucleus. We are very known for being having the most electric charge and being more massive than the others. So when we play for the gains against them, it's dangerous if released by the radioactive atoms in the human body. So in the transmutation stage of in alpha, when an atom emits in alpha, it's a different element. So the process of changing from a different element to another is through nuclear decay, and that's because of unstableness. And so in alpha decay, 2 protons and neutrons are lost in the nucleus. So in the new element, the atomic number is 2 less than the original one, and the atomic mass is 4 less than the original one. And so we have a motto, and our motto is the original charge of the nucleus is equal to the sum of the charges of the nucleus and the alpha particles that are formed. So if you would like to be part of the alpha sorority, please take these words into consideration, and I wish you the best of luck.
Hi, I'm Elizabeth, and I'm from the beta sorority. In the beta sorority, basically what happens is we're like a electron from another sorority that emitted us, and also when they emit us, they also have like a neutron and it decays into a proton, so like one of them like changes into something else. But the electron, which is what we are, and we're emitted from this unbalanced atom through radioactive decay, we're called the beta particle, and that's why we're the beta sorority. And so basically we're just kind of like thrown away, left out. And because that atom that gave us away, because they turned one of their neutrons into a proton, their atomic number increases by 1, but their atomic mass doesn't, because the total number of protons and neutrons doesn't change. It like evens out.
But basically, so we're like a little more penetrating than alpha particles, but not quite as penetrating as gamma, because we're also kind of tough, because we've already been like thrown out, so we kind of know how to handle ourselves. We're also a little faster because we know how to we focus on a lot of like running and stuff here. We're so fast we can pass through paper, but we can't pass through aluminum foil. We're still working on that, you know. And overall, it's great to be a beta particle, so good luck in sorority week.
That's it for today. I'm your host, Elizabeth Science, and we'll see you next time,